All right. Not moving. This diagram is called a food web. It shows the relationship between foxes and voles. What does this diagram show other than that relationship between foxes and voles? What does it show? It's pretty straightforward. Anyone besides Chris have an idea? Anyone besides Chris and Joe have an idea? Sienna, I see a hand. Give it a shot. Yeah, that the foxes eat the voles, right? We've probably seen this at some point in our life, but this diagram is showing that the foxes get their energy storage molecules from the vole. In a food web, the arrow points in the direction that the energy storage molecules move or are transferred. It's not who eats who. This diagram does not show that the vole eats the fox. That would be really silly, right? So it shows that the energy storage molecules come from the resource population of the vole to the consumer population of the fox. In the last few lessons, we've gathered evidence that the more energy storage molecules lead to more reproduction. We saw that in both experiments, and we learned a little bit about that in the article. It doesn't want to work. Now we're going to use that knowledge to try to increase the number of births in a population in the sim. We're going to use the 3 populations mode. We're going to focus on increasing births in the wee bug population. These are the wee bugs, these little caterpillar-looking things. First, we need to figure out where the wee bugs get energy storage molecules. In the sim, there's going to be this, it looks like a share button, but it's actually the food web. So when you click on that button in the bottom left, you will get the food web. So here is a food web showing populations from the sim. Think about the question below. Where does the wee bug population get energy storage molecules? If you're having a hard time seeing it, remember you can open the slides on your Chromebook. Kara, where do they get their energy from? The green leaves, right. The energy or the arrow is pointing from the green leaves to the wee bugs. So they get their energy storage molecules from the green leaves. So we just said that. In the sim food web, we can see that the energy storage molecules as orange dots on the arrow pointing from the resource to the consumer. So this arrow is not polka dotted just for looks, okay, to make it look pretty. Those dots are representing the energy molecules that are going from the resource population to the consumer population. You can also see that the wee bugs and the green leaves have these numbers with little dots. That's showing how many energy storage molecules that population currently has. Okay, so you can watch to see increases and decreases. We're going to use the sim to help us answer this question that we have been investigating for quite a while now, which is what can change the number of births in a population. We're going to watch a video demonstration of the sim. The test that is shown will be different from the other tests that we will run. Not that much different. I'm not sure why they say that, but it will help demonstrate the features of the sim. So I'm going to play the video up here.
In this activity, we will test your predictions on what change to the green leaf population will increase the births in the wee bug population. I will test both predictions, starting with increasing the green leaf population, and we'll do that in 3 populations mode. So first, we'll let the sim run for about 20 time units before making the change. Now I will open the population control panel and increase the green leaf population.
Notice she's really adding a lot, not just 1 or 2.
We will lock the population and then let the sim run for at least another 20 time units. So now we're in Analyze, and we will look at the births and deaths in the weed bug population before and after the change was made. So before the change was made, there were 23 births and 32 deaths in the weed bug population. After the change, there were 109 births and 26 deaths in the weed bug population. So now I'll go back and reset the sim to test the other prediction. Again, we're going to let the sim run for 20 time units before making the change. So now I'm going to test a decrease to the greenleaf population.
Again, she's making really big changes, not just a couple.
And we'll let the sim run for at least another 20 time units. So now we're in Analyze, and we want to check the births and deaths in the weed bug population before the change was made. And here I can see that 14 were born and 23 died before the change. Then after the change, 5 were born and 37 died in the weed bug population.
All right.
In this activity, we will test.
Go away. So before you run your test, you're going to make a prediction about what change to the greenleaf population could increase the number of births in the weed bug population. So we're trying to get weed bugs to go up. Go ahead and go to Google Classroom and open up number 2 for today. And the directions say to make a prediction about how to increase the number of births in the weed bug population, then make observations in the sim. So when you get your document open, this is what it should look like. We know that weed bugs get energy storage molecules from eating green leaves. What change to the green leaf population could increase the number of births in the weed bug population? You want to highlight one of these. What are you going to do? You're going to have more green leaves or less green leaves to get the births to go up? Just pick one. You need to highlight it. Weed bugs, we want to go up, and they eat green leaves. So do you want them to have more energy available or less energy available? Once you have your prediction, you want to click the blue link to open up the sim. And then you can either work through the directions on your own or you can follow along with me. Oh, there we go. Does anyone need help getting to this point? We're all good? All right, you want to click 3 populations. Oh, that's my alarm. Isn't that pretty? Okay, so now that you're here, if you've already been letting it run, you want to click reset. And you want to let it run for 20. So here's your time. When it gets close to 20, hit pause. It's okay if it's not exactly 20, but you don't want it to be over 25. You then want to click on the side here, the population control panel, and you want to put in your prediction. So if you said increase green leaves, you want to hit plus a lot of times, probably until you're into like the 200s.
You can hold it, yeah.
You can hold it. Fantastic. If you picked decrease, then you want to Decrease them way down. In the middle. Yep. You're welcome. So let it run for 20 and hit pause. And then do your populations. Once you have your green leaf set, you want to hit lock.
Do we put the green leaves at like the highest?
Yeah, as high as you want to go. You want to lock it.
Yeah.
And then you want to hit play again for another 20 seconds. Again, it doesn't have to be perfect. And then you're going to analyze, which is up here in the left-hand corner. This is where you get your range finders so you can move this thing. It's difficult if you don't have a mouse. You want to set it so you're at about 20. I do a little bit before, like 19. And then you get your data for the wee bugs. Died and born. You put that data here. Once you've gotten that far, you want to put your before and your after. Sorry. Once you do that, then you want to answer the questions. You're obviously going to have to answer the questions at home or in study hall today, but you want to finish both pages and then turn it in.